following program was provided by an independent producer solely responsible for its content. The opinions expressed do not necessarily represent the views of this station, its staff, board of directors, or underwriters.
Welcome to Gate City Chronicles. I'm Kevin Avard, your host, and today I am joined with the Hometown Forecasting Services, Mr. Rob Carolan. Thank you very much for coming on the show.
You're welcome, Kevin. Not a problem.
Well, like I was saying earlier, before we got so rudely interrupted, that you do radio in the morning.
I do.
Oh,
I am a broadcast meteorologist as well as the owner of Hometown Forecast Services.
Right.
Yep, I'm on about 50 or 60 radio stations a day. Every morning, people get to listen to me from Boston to Jamestown, North Dakota to the Caribbean, from Jamaica to the Virgin Islands to the little island of Dominica in the West Indies.
And little do all these people know that you're sitting here in Nashua, New Hampshire.
Exactly. I get that all the time. Boy, here in Nashua, we have, a forecasting company that services clients all over, North America and the Caribbean.
Yeah,
But
you have
that's
a
what we
nice
do.
executive building that you're sitting in with lots of
We do.
windows.
No windows, and that's always a big joke. Everybody says, how can you forecast the weather, without windows? It actually helps because, we're not distracted. A lot of our clients are outside of New England, so,
Right.
We're looking from the big window out in outer space, satellite photos, they allow us to see what's going on.
So we had a conversation a little bit about the satellites. Some of the satellites aren't really up to the par these days.
No, they're not. In fact, there's an issue right now. We have two satellites, Goes East and Goes West. Goes East watches the eastern United States and the Atlantic Ocean. It's very important for Atlantic hurricane forecasting. Goes West watches the central and western United States. Goes East has been failing because it's an old satellite. The federal government didn't place any money to replace it.
Right.
So they're concerned that if it drops out, they're going to have Goes West watch the entire Atlantic, Gulf of Mexico, and Eastern Pacific, and it's a big job for an old satellite. They are in the process of developing a new GOES satellite. That'll go up, though, in 2015. So the concern over the next 18 months is that we may have an issue with, a failure of one of these satellites, which would cause big problems for we meteorologists, wanting to know what's going on in the Atlantic during the summer, which is important.
Well, that draws a question then. Usually when they're tracking these hurricanes, we have the European model and then we have the American model. And it seems to me like, and I'm almost ashamed to say, hey, I'm going to watch the European one because it seems to be a little bit more accurate.
And that's how I built my business.
Really?
Because I was taught about that back in college. There is what has to be, and a lot of people don't realize this. When I was going to college, I was instructed by a professor why the European model is always going to be better than the U.S. model forecasting long-range weather.
And it has nothing to do with our satellites.
It has nothing to do with our satellites. It has to do where resources have been devoted. The United States suffers more severe weather than any other country in the world. Most severe weather takes place in short periods of time. Tornadoes occur quickly, hailstorms, flash flooding, high wind events with lines of severe thunderstorms. So the United States, the National Weather Service, has devoted its resources into modeling correctly short-term weather events that happen between 48 hours out and 10 minutes out. So that's where our resources have been. Europe, on the other hand, is affected by big Atlantic lows. They develop in the western Atlantic, they march across the Atlantic, and then slam into Europe, much like we see happen on the west coast of the United States in the winter. So the Europeans have devoted their energy, their resources, their more or less brain power into developing models that are good forecasting long range. Now, I graduated college in 1989, so I was taught in the 80s the European model was better. It's just recently that forecasters here in the United States have looked and said, oh, the European does a good job. I can tell you when I first started my business in 2001, I would be on the air with radio stations and they'd be like, how do you know this storm is coming? Nobody's talking about it. I'd be like, well, we're looking at, data and it suggests the storm coming. We were looking at the European. So a lot of my compatriots have been slow to the table to find out about the European.
Right.
What's happened though is the US model, they've tweaked the physics package. We use these enormous numerical equations to break the atmospheric motion down into math, and we solve the problems. Well, the U.S. tweaks to the physics have kind of made the model worse. They haven't made it better, where before the U.S. model and the European kind of did
Mirrored a little bit
They,
each other,
yeah,
right.
they mirrored one another. You could tell what was going on. GFS would be a little slower than the Euro picking something up. Now the GFS may not do as well as the Euro.
GFS.
It stands for Global Forecast System. That's
Right.
the U.S. model
Right.
that we look at. The best example was Hurricane Sandy and
was
what
just gonna-
happened with that.
right.
The European model picked up on it 10 days before it happened.
Slammed it right
And it
bullseye.
it said 10 days out, it had it hitting somewhere in the mid-Atlantic. It was northern Delaware, southern New Jersey. The GFS had a storm developing south of Jamaica, but didn't really know what to do with it. And for several days, kind of took it up the East Coast, sometimes took it into Maine, sometimes took it into southern New England, sometimes took it into the mid-Atlantic states, where the Euro kept hitting the same spot every time. We have a saying in my office, you ignore the Euro at your peril. If you don't pay attention to what that model says after several runs where it has forecasted the same thing, you're nuts.
Did they forecast the perfect storm?
They did, but that was back, the models weren't as good back then. The perfect storm was a different situation. What happened with the perfect storm was we had a case of retrogression, and the storm moved westward, but it did it in a different way. The perfect storm was a merger of a large Atlantic low, a hurricane coming up from the south, Hurricane Marolan, and a cold front dropping in from central Canada. All three of them merged well off the coast of New England and then backed up towards the New England coast. I knew it as the Halloween storm. I didn't know it as the perfect storm because it came in around Halloween weekend in 1991, and we had all this rain and damage along the coast from Gloucester down to Boston. Cape Ann got hit pretty hard.
Yeah.
So it backed up. This storm, it was two storms. We had a big nor'easter develop off the East Coast that captured a hurricane in its circulation and threw that hurricane back towards the coast of New Jersey. We had never seen that happen before, but the European model looked at the data and said, this storm is going to make a left-hand turn, and it did.
That's amazing.
And for a lot of people, when we called our clients 7 days out and said, look, we think this is going to happen, when I spoke to our client in New York City and said, we think the New York City subway tunnels are going to flood in lower Manhattan, the Brooklyn Battery Tunnel, the tunnels over to New Jersey, they couldn't believe us. They were, no, this has never happened before. I said, well, there's always a first time for everything. And we said, the model is predicting a humongous storm surge along Battery Park and along Raritan Bay. See, that type of storm is the worst case scenario for New York City. It was much like Katrina was in 2005 in New Orleans, because the similarity between New York City and New Orleans is you have these bodies of water close to the city. You have Long Island Sound and you have a New York Harbor. With the storm that we had, Sandy, because it was a hurricane, it's pushing these enormous swells out ahead of it, big ocean waves. They go in through the Verrazano Narrows into New York Harbor. They cause the tidal levels to come up.
Right.
But because you have a very strong easterly surface wind with the nor'easter, you're funneling the water from Long Island Sound into New York Harbor through the East River. So the water's coming in from the east, the water's coming in from the south. It has no place to go. The only place it goes is either onshore into Battery Park, into eastern New Jersey around Hoboken, or it goes up the Hudson River. They had tidal flooding up the Hudson River 110 miles. The same thing happened with Katrina.
That's amazing.
The flooding with Katrina
Right.
went all the way to Baton Rouge, Louisiana, which is 110 miles north of New Orleans. So we had similar situations, easterly surface winds, big surging waves up from the south, and any city that sits like New York or New Orleans, they're going to be at the apex of all of that water, and you're going to see, horrific flooding.
So somebody's going to say, well, geez, I can't remember all these storms. Is this the absolutely proof in the pudding that global warming, man-made global warming, is the cause of all of this?
And the answer to that is no, because we don't know what happened on Long Island 400 years ago.
Right.
We can't go back to the Indians and say, what temperature, what storm readings did you have on October of 1485? There was nobody living taking weather measurements. Global warming is very interesting. The globe has been warming all the time. Climate, when they talk about climate change, the study of climate is the study of change. If you look at the Earth's weather over the last let's say 6 million years, the climate has been warmer and it's been colder than where we're currently living in. Just 10,000 years ago, this entire region was covered with an ice sheet that was a mile thick.
Right.
Okay?
White Mountains can prove that.
Exactly. The tips of the White Mountains were all that were sticking up. all you have to do is go around the city and you see boulders that were left behind by the glaciers.
Right.
They dropped off the front of the glaciers as the glaciers retreated. The Great Lakes were formed by water pouring out of the glaciers, and they filled large depressions.
Was that
very
because of
large depressions.
bonfires, or?
Well, what it was is
I'm kidding.
What happened was they're really not sure. They think it may be due to changes in what we call the global oceanic haline cycle. Cold water pours off of Antarctica. It goes. What happens is as ocean water freezes, its salinity changes. It becomes more salty. The colder the water becomes, it starts to sink. Cold sinks, warm rises. So you have super saline water in the Antarctic Ocean or the Southern Pacific Ocean pouring down to the bottom of the ocean. That then spreads northward towards the equator. It takes decades to get there. This helps produce a global cycle in the oceans of circulation. The Gulf Stream is an example. The Gulf Stream takes warm water from the Gulf of Mexico through the Florida Straits up the East Coast. It's diverted by Cape Cod. It goes to Europe. You probably don't know there are palm trees in Southern Ireland.
You did tell me that,
Okay.
and
And
I
they're
felt
there.
very smart because I knew that.
Because the warm water is being diverted towards Europe. So it helps affect the climate. One of the reasons the poor pilgrims coming over to North America got creamed was they said, well, we're going to go across the Atlantic to a latitude that's similar to Spain, and it's going to be nice and warm. They didn't realize how the weather works, that the Atlantic side is cold, north of Cape Cod, and the cold air comes off the continent, so they froze. They weren't expecting the type of climate that they get on the eastern side of the Atlantic because the Gulf Streams brought all that warm water across.
Right.
There is a belief that at some point that circulation collapsed, that warm water was not being transported from the Gulf of Mexico up into the northern latitudes, which allowed colder air to continue to penetrate longer and longer each year down from the poles and allowed glaciation to occur.
Could have been because of a continental shift or something?
Not so much a continental shift, just a shift in the circulation of the water in the ocean. That flow of warm air and see, the ocean and atmosphere are interlinked. The circulations on the ocean are overlaid with circulations in the atmosphere in the same direction. So if you break down what we call the semi-permanent Atlantic high, and you're no longer moving that warm air northward, well, there's a problem. The cold air can now stay around longer. It stays on the mountaintops first. Maybe Mount Washington doesn't lose its snow all year.
Right.
It's there. People are skiing Tuckerman's Ravine in July and August. And if that continues to get deeper and deeper and deeper, cold snow cover starts to create its own weather. It has a very high albedo. It's like the paper on your desk. It reflects the light. All of it, that's striking it. So at night, the air gets colder. It doesn't get as warm during the day, which leads to more snowfall. And you
Right.
get into what we meteorologists call a positive feedback mechanism. It starts to breed on itself. And all of a sudden, now you're starting to expand glaciers out of the White Mountains, out of the Great Mountains, out of central Canada. All of a sudden, you've got an ice pack. And 10,000 years ago, that extended here. One of the things I've learned that I never realized is there were no earthworms in North America because they had been frozen out. The ground got so frozen because of the glaciers, earthworms disappeared. Well, we all have earthworms now. They came from Europe. They came over in ballast soil from all the ships coming over from Europe. They dumped the soil out, the earthworms were in the soil, and they got into the ground here. When the colonial people came over here and settled North America, the leaves under the trees in the forest were 4 feet deep. They called it duff. So we've changed the climate by settling it. And there's so many things that go on. For somebody to broad brush and say, man is the reason that we're seeing this change is a bit disingenuous. The climate has changed a tremendous amount over the entire time the planet has had life on it. I can give you a couple of incidental examples. Greenland is called Greenland for a reason. When the Vikings went across to Iceland, Iceland was frozen, and that's why they called it Iceland. When they got to Greenland, it was green. Why? Because in the 13th and 14th century, the climate was warmer. The ice sheets on Greenland did not exist as far south as they are now. In fact, now that some of the snow cover is melting along the coast of Greenland, they're finding old settlements that were covered by snow as the climate cooled. There was a period of time between the 15th century and the 19th century where it's called the mini ice age. It got very, very cold. When you read Dickens' A Christmas Carol, he talks about snow in London. How often does it snow in London in the winter? It's a relatively rare event.
Right.
He talked about the cold winters because the winters were cold then. The winters have been getting warmer in North America, in Europe, since the mid-19th century. When's the last time you had a grape wine from Scandinavia?
You know what?
Scandinavia is
can't
not known
recall.
for its wine. The
Right.
Vikings used to grow grapes and make their own wine. The climate in Scandinavia right now is too cold to grow grapes. That was only 1,000 years ago.
So when, I do recall, and I mentioned this earlier, that I remember about 10 years ago that Ted Danson, the guys from Cheers, said, in 10 years, the ocean's going to rise 2-3 feet or something, and we're not going to know the Earth like we used to know it. And last I checked, it hasn't really risen up that far. Maybe
No, it's come up a couple inches.
Inches.
What's happened is you have to look at the big picture. Right now, if you look at the atmosphere and you sample how much carbon dioxide is in the atmosphere, we're seeing about 400 parts per billion. That's the most we've had in the last 6 million years, okay? So the Industrial Revolution has put more carbon into the atmosphere. What's not understood very well is how much of that carbon is tied up by the oceans, by plant matter. When you burn a tree, and you burn a log in your fireplace, you're releasing carbon that tree stored through photosynthesis. It grew during the summer, it absorbed light from the sun, it took water out of the soil, and it took carbon dioxide out of the air, split the atoms, turned it into food, and that carbon then gets bound in the cellulose of the wood. So you're releasing that carbon when you burn the wood. That's how carbon goes back into the atmosphere. We do the same thing when we burn gasoline. That gasoline is refined from oil, which is from plant matter. The vast forests that grew on the planet when the dinosaurs were roaming has been converted into oil due to heat and pressure. So what we're doing is we're just taking what existed in the atmosphere at some point and putting it back.
Just like now, these forest fires this massive forest fire,
Yosemite.
Yosemite. Somebody said that one fire is putting out as much carbon as all the cars and factories that for the last couple of years or something. Like that.
I don't know the amounts, but it's going to be a large amount. We've burned an area right now the size of the city of Chicago. Now that carbon's been released into the atmosphere, and that's one of the concerns. All you have to do is look at the planet Venus, which is our closest neighbor in the solar system. The planets are roughly the same size. They're closer to the sun than we are. Their atmosphere is about 97% carbon dioxide. The surface of the planet is 900 degrees. So if you get a runaway greenhouse effect, you've got big problems. What we should be doing in regards to global warming or greenhouse warming is telling everybody, look, this is not a good thing to be doing. At some point, we are going to alter the climate. My concern is how the public interacts. I spent my entire career as a meteorologist trying to warn the public about bad weather. And one of the things I learned quickly is if you hype everything, no one pays attention.
Right.
If you're always running around like the little boy who cried wolf, or Chicken Little, the sky's falling, the world's going to end, after a while it doesn't happen, nobody pays attention to you. And this is a pretty serious thing, because if we are increasing the amount of carbon dioxide in the atmosphere, one of the places we're going to start to see it happen or affect first is the ocean. Well, what's it going to do to the ocean? Yeah, the ocean's going to rise, and it could rise significantly.
Will that slow the currents?
Well, it may change the currents, but what it's doing is it's changing the acidity of the ocean. Carbon dioxide is a gas in the atmosphere. It lies over the ocean. Some of those carbon molecules jump into the ocean, like some of the water vapor molecules jump out of the ocean. Well, when you put carbon dioxide in water, you form carbolic acid. So you're going to change the pH of the ocean. Now, we don't want to do that because right now, everything that swims in the ocean is used to the pH being in a certain range. You start killing off all of the fish that we eat, all of the shrimp we eat, the lobster we eat, that's a big problem. The other issue you run into is you'll affect coral. A lot of the concerns right now about what's happening to coral reefs is the ocean is becoming acidic in a different way than coral is used to. Coral actually takes minerals out of the water to build its shell to produce coral reefs. If you change the acidity of the ocean, they're no longer going to be able to do that. They've adapted to a certain acidity. It was like the big problem when everybody talked about global warming is going to kill you. No, global warming is not going to kill you. It's going to alter how we live.
Right.
What's going to kill you is a hole in the ozone layer.
I was just going to ask you, I haven't heard about the ozone lately.
Well, because people jumped on the ball and said, hey, look, this is really bad. It was a much faster curve. Solar radiation, ultraviolet radiation coming through the atmosphere is going to kill people much more quickly, especially if you're out. I've had skin cancer removed from my body. Skin cancer levels are rising rapidly. The ozone hole formed very quickly. But because people were diligent and they said, look, we're seeing it, we're seeing the rise in cancer rate, here's what we need to do, here's how we have to act.
And they did.
They cut back on chlorofluorocarbons,
right.
And the ozone hole, while it's still around, should start to get better over the next 75 years. So we've taken precautions. But what we did is we didn't panic people. We kind of explained to them what was going on. Here's the proof. We know it's never existed. This is what we need to do. And the same thing needs to happen with carbon dioxide. To turn around and say, we can't burn fossil fuels right now is absolutely ridiculous.
Right.
Our civilization is based upon burning fossil fuels. What we need to do is explain to people why we need to cut back on doing it and shift towards doing other things.
Right.
But we do it in a multifaceted approach, and we don't try to panic everybody and say, throw your car away, walk to work, even though it's 25 miles, well, you're out of luck. You try and do it intelligently with common sense.
Right.
And I think that's what's lacking here. It's, a lot of people haven't looked at this from a common sense standpoint and said, how much of it is naturally driven, say by solar cycle, how much of it is driven by the natural occurrence of the climate, how much is man. If we cut back on carbon dioxide emissions, it's certainly going to be a positive for future generations. Is it going to kill all of us? No, but it will alter the way we live if we don't do something common sense about it.
How does a city or an organization contact you to hire you for your services, or you just put it out there?
Well, we put it out there through our website. Most of our business has come through referrals. We do everything very, very old-fashioned. Everybody talks about computer models. Our staff has an experience level of about 120 years combined looking at the weather. And the way we forecast is what we call a consensus forecast. All of the meteorologists on the staff discuss the forecast, and we come up with a forecast based upon what all of us think. And when you look at consensus against computer models, against a single meteorologist, consensus wins, because you're taking the broad view of what's going on in the weather, and you're discussing it out, fleshing out all the possibilities, and coming up with the best case scenario. We're not into hyping up the forecast. I leave that to the guys at the local television channels. They're ratings driven. There's a philosophy behind a weather forecast. The philosophy is TV, they want you to come back and watch the commercials, at least for commercial television.
Will it rain tomorrow? We'll be right back.
There's a possibility, exactly. Or no, there'll be a flood tomorrow. We'll be right back. How many people will die? That's how the way it's become. When I was a kid, it was, will it rain tomorrow? Now it's the end of the world. Then you've got the National Weather Service, whose job is to try to protect life and property, but they're a government agency. So that means they're not a very flexible entity. Then you have us, a private weather service that is driven by capitalism. Mm-hmm. And what that is we take your money.
I know what capitalism is.
Yeah, we take your money. If we do a bad job, you fire us. Mm-hmm. And the fact that we've been in business almost 13 years and there is so much free weather data out there is kind of a testament to the job we do. Manchester Airport is one of our clients. And I know for a fact, as the recession hit, the city of Manchester had to cut the airport's budget because the number of people traveling through the airport dropped. Well, we helped them with their budget because they use a treatment on their runways that's much more expensive than what we use on our local highways. It burns through snow a whole lot quicker. It makes it much safer for the airplanes to land. But to treat one of the runways at Manchester Airport, it's about $12,000 to put this chemical down. Well, if they pick up a phone, call me, and I say, don't treat tonight, and they don't treat the runways, and that forecast works out, my contract is just paid for itself for about the next 5 or 10 years.
Their budget and lives actually depend upon it.
Exactly, yes.
Wow.
It's, for us, I can't think of a client that we have that's more sensitive to, our responsiveness and our accuracy than an airport.
Do other municipalities?
We do. We service a number of municipalities in southern New Hampshire and central New Hampshire, also in northern and eastern Massachusetts, all the way down to Connecticut and New York. But as I said, we do things the old-fashioned way. We don't have voicemail at my business. If somebody doesn't answer the phone, it's either because they're on the phone with another client or they're using the facilities. We feel if a client picks up the phone and calls us, they deserve to get an answer.
Right.
And we take a tremendous amount of calls during the winter. And to be honest, what we do is we kind of hold the client's hands. One of the services we provide here in Nashua is during the winter season, between November 15th and April 15th, we talk to Mark Conrad. So Mark will call me at 4:15 in the morning before he has his conference call.
And then he calls us at 5.
With the other superintendents.
Of course
and he'll say, what do you think? I've gone outside, it's not doing a whole lot. And I'll say, well, Mark, when I came in at 2:30, it wasn't doing a lot. It looks like it's going to work out. We're concerned, a lot of people say nowadays, gee, the schools seem to close a whole lot faster than they used to. Well, because you've got so many kids walking to school. That's our big concern. How are the walkers going to do? So, you may say, hey, it wasn't that bad, but we're concerned about kids not being able to be on the sidewalk and they've got to go out in the street. Are they going to get hit? Can you see them in the heavy snow? we take that type of stuff into consideration for the city. All of our clients, it's different. We kind of custom tailor fit the forecast to their need.
And how do they get in touch with you? How do people, if they want to hire you for your services?
If they want to hire us, they can call us at 204-5430 or just check out our website at hometownforecastservice.com. We have a site that more or less explains what we do, how we do it for our clients. And, we kind of, right now we just started, it's going to sound funny, we just started a trial with Water Country in Portsmouth.
Oh.
They offer a weather guarantee. If it rains for more than an hour, they give you admission to the park another day. So for us, they're very sensitive to severe weather, rain, and lightning. So right now, we're doing a trial for them to tell them, hey, this is what we can do for you. We can help you do what you do better.
Do you forecast the lightning up in the mountain area?
What we do is we'll forecast whether or not thunderstorms are going to occur. We actually work with another company that gives us real-time lightning data. So we actually can offer a service where a client could sign up with us and our vendor and be able to get lightning information sent right to their phone.
I watched the show the other day. It was, and I'm running out of time, but it was called Prospectors, and they're up they're up in the mountains. They're looking for gold or whatever, and they see a storm, and I thought, okay, so what? But it's a life-threatening situation if you're up in the mountains because lightning strikes at the highest point.
Exactly, and they were exposed.
Yeah.
So there's going to be a huge concern about, not only lightning, but flash flooding if they're in heavy equipment and they're in a low area digging. All of a sudden, if they get an inch of rain and it comes out of the mountains and runs downhill, they get trapped in their equipment.
Do normal people, I say normal people, do people just call you up?
They do once in a while. We'll send them to the National Weather Service because most of the data they're looking for is, hey, how does the weekend look? And I'll say, hey, here's what the Weather Service has.
Check out my show on the morning. You're on the radio.
Listen to me on the radio. But what we'll do is we'll send them to the Weather Service. We're more dealing with clients that have needs for, say, paving, excavating. The city uses us, the city of Nashua uses us year-round. In the winter, it's for snow and ice removal.
Like Audley's with the highways and stuff
Exactly.
like that.
But our forecasts also go to the stormwater and sewage treatment plant because when, Nashua it was just in the paper recently, they're trying to get permit changes in the permitting with the EPA because we still have stormwater systems here where if there's an overflow, the stormwater and the wastewater go into the Merrimack River.
Right.
So we try to keep the forecast letting the stormwater and wastewater people know whether or not there's going to be an event where they need to be concerned about that type of stuff. So they'll look at that.
One last question. Did you predict the October surprise storm that we had a couple years back?
Yes, we did. In fact, you're talking about the big snowstorm.
Yeah, well, the ice storm that shut down the power in the city.
Well, yeah, but it was the snow. It was
Right.
because we had so much snow and the trees were fully in leaf. That was actually a very interesting event because we were concerned it had been a very mild fall up until that storm. We hadn't had a frost until that snowstorm. So all of the trees, particularly the oak, stayed in leaf. And we were really, really worried about what was going to happen. And we actually got the town of Exeter as a client because the Department of Public Works Director in Exeter was out deer hunting outside of Keene. She got an email from me in the woods saying this storm was going to cause big problems for downed trees and power lines. And she was like, we have to get out of here. We have to get out of the woods now. And fortunately, it did. Where she was hunting, they got 30 inches of snow. So it became impassable. Once you got up to Jaffrey, anywhere with elevation, we were lucky here. We only got 10 inches of snow. But Concord to Jaffrey, they got between 20 and 30 inches of snow, and the trees were still fully in leaf. So it was big problems. But yeah, we did forecast it. In fact, we tried to talk to the fine folks at PSNH to see if we couldn't do something with them, but they're working with another vendor.
Well, maybe they'll smarten up.
Well, it would be nice if they did.
All right. Bob, I appreciate you coming on the show.
You're more than welcome.
And that's Hometown Forecast Service, and located here in Nashua, New Hampshire. And we really appreciate
Not a problem.
man
Anytime.
of your caliber coming on our show.
It was fun.
Thanks for watching Gate City Chronicles. Until next week, we'll see you. Thank you for watching Gate City Chronicles. And we want to thank our sponsor, Aardvark Dean of Clean, the carpet cleaner in Nashua. You can reach him at 603-630-1743. And if you would like some more information about Gate City Chronicles or want to be a guest, contact me at gatecitychronicles@gmail.com. Until next week, thanks for watching.
preceding program was provided by an independent producer solely responsible for its content. The opinions expressed do not necessarily represent the views of this station, its staff, board of directors, or underwriters.